वेलकम स्टूडेंट्स। आज आम वर्क एनर्जी थ्योरम विषय पढ़ा। फर्स्ट ऑफ ऑल लेट्स गो टू द स्टेटमेंट। ओके, इट स्टेट्स दैट the work done by the net force acting on the body is equal to the change produced in the kinetic energy of the body. That means if a force is applied in the body, okay, then what happens? The body gains some energy, okay, due to the motion, I can say. That means kinetic energy is there. Okay, whenever there is a motion of the body, there is a kinetic energy. You all know it. Okay, so ये आम बाहर करवा कौन द टोटाल वर्क डन और काइनेटिक एनर्जी भितर गोटे रिलेशन। ठीक अच्छे, गोटे फोर्स जो गोटे बॉडी उपर अप्लाई होचे से बॉडी किसी बाट डिस्प्लेस करूँ, तार किसी एक्सीलरेशन रोथो। ओके, तो से कौन हुए तार इनिशियल वेलोसिटी और फाइनल वेलोसिटी, दैट मीन्स द वेलोसिटी विल बी चेंज्ड। वेलोसिटी जो चेंज होची किसी एक्सीलरेशन प्रोड्यूस होची, यू नो इट। ओके, रेट ऑफ चेंज ऑफ वेलोसिटी इज एक्सीलरेशन। तो से सब पैरामीटर को लेकिन आम कौन करवा ना काइनेटिक एनर्जी आउ वर्क डन भितर गोटे रिलेशन एस्टाब्लिश करूँ को आम वर्क एनर्जी थ्योरम एक्सप्लेन करुँचे। ओके, वर्क एनर्जी थ्योरम पे मेनली दुईटा हेड रे पढ़ा। दैट इज फर्स्ट इज फॉर ए कांस्टेंट फोर्स व्हेन ए कांस्टेंट फोर्स इज अप्लाइड इन द बॉडी। ओके, एंड द सेकेंड वन इज फॉर ए variable force. Okay, I will go for that after this one. Okay, first of all let's go to the work energy theorem for a constant force. Okay, this one. Acha, here as I have told, it is considered a body of mass m. Body ro mass है m, तापर में force केते apply करूची ना F, capital F. That is a constant force acting on the body. Acha, for that applied force an acceleration is there. Acceleration is produced. So body ro acceleration kete heji bole, that is a, small a. Acha, u is the initial velocity. Okay, after giving that force what happens? The velocity changes, that is the final velocity. S, small s कौन होची ना displacement produced by the body. We know the equations of motions. Okay, equation of motion तुम सब जानी छो। So equation of motion ये कौन आम पाखे v u a s ये सब जिन डाटा अच्छी आम पाखे गिवन। सो पकई पारे कौन v स्क्वायर माइनस u स्क्वायर इज इक्वल टू 2as. ओके, अच्छा, नाउ वी हैव टू डू सम मैथमेटिक्स विथ दिस। ओके, कौन पाई ना ये वर्क एनर्जी थ्योरम टाको प्रूव करबे। ओके, केमती कौन करिवे बिले, let us multiply half m by 2 in both the sides of this equation. ए इक्वेशन रे हमको कौन करिवार अछि, both sides रे half m हमें मल्टीप्लाई करिवा, so that value will not be changed. So half m मल्टीप्लाई कर देले v स्क्वायर माइनस half m into u स्क्वायर is equal to half m into 2as. Okay, so by solving this equation I am getting half mv square minus half mu square is equal to mas. Okay, अच्छा, before this we have gone for the Newton's second law. Okay, from Newton's second law we have derived the formula for force. So ma is equal to f or f is equal to ma, you all know it. अच्छा, so in place of this m into a I can put f here. Okay, so half mv square minus half mu square, this equation becomes ma. In the place of ma I have put f and s is here. So fs, what is fs then? That is work done, w. So kf minus ki is equal to w. What is kf? That is final kinetic energy. That means final velocity थिला केते v. So half mv square है कौन फाइनल काइनेटिक एनर्जी, इनिशियल वेलोसिटी केते थिला u. So इनिशियल काइनेटिक एनर्जी केते होबो ki. So kf minus ki, that is equal to w. Okay, what is this then? Change in kinetic energy, that is kf minus ki is equal to work done on the body by the net force. Are you clear about it? This is the proof of work energy theorem. Clear? For a constant force. Okay, समझते बुझ पारले बिले। Okay, let's go to the next part. What is this? That is work energy theorem for a variable force. work energy theorem for a variable force. अच्छा. Similarly, let us consider a body of mass m. So body ro mass है m. आम F force apply करुचे. Okay, force applied, variable force जो apply करुचे, that is capital F. Okay, that is capital F. बर्तमान कौन है पे जो कैपिटल एफ आम अप्लाई करुचे बॉडी ऊपर फोर्स गोटे डिस्प्लेसमेंट है स्मॉल डिस्प्लेसमेंट है के डीएस. सपोज वी हैव टेकन स्मॉल पार्ट ऑफ द डिस्प्लेसमेंट दैट इज प्रोड्यूस्ड इन द डायरेक्शन ऑफ द फोर्स माने बॉडी रो फोर्स आम जो डायरेक्शन में अप्लाई करूँ डिस्प्लेसमेंट भी से डायरेक्शन में हो. फोर्स एंड डिस्प्लेसमेंट बोथ आर एक्टिंग इन द सेम डायरेक्शन. देन व्हाट इज द एंगल बिटवीन देम? What is the angle between them? What is the value of theta? Theta is equal to 0 degree here. Clear? Achha. As the displacement is small, we have taken the small displacement. So small work done will be there. That means dW is equal to how much? F dot ts. That is equal to F ds cos theta. Here theta is equal to 0 degree. So cos 0 is equal to 1. So F into ts. dW is equal to F ts. Equation 1. Okay. You all know about the Newton's second law of motion. Just I have told you that is F is equal to ma. Okay, in place of a you can write rate of change of velocity, that is acceleration. Ma, that is equal to m into dv by dt. Clear? Give it as equation 2. Next thing, putting equation 2 in equation 1. Okay, dw is equal to how much? dw is equal to f ts. So just put the value of f in equation 1 from equation 2. Okay, so how we can write? dw is equal to m dv by dt into ds. पिला माने एठी हम सिंपल अलजेब्रा गोटे करबा. जदि तुम डेरिवेटिव पढ़िथिबो आराम रे बुझि परिबो m dv by dt into ds. एठी dt र प्लेस टाको जस्ट हमें कोन चेंज करि परिबो. ओके, इट्स क्वाइट नेचुरल. सो m into ds by dt, dt टाको एठी के नै आसो into dv. So ds by dt into dv. What is ds by dt now? Rate of change of displacement. That is your velocity. Okay, ds by dt is equal to v. So this equation becomes dw is equal to mv dv. Okay, give it as equation 3. Okay, achha. Now if the applied force increases, okay, if the applied force increases the velocity, that means the applied force increases the velocity. Due to the application of force, velocity increases. We have just discussed now that the velocity increases from u to v. Initial velocity was u, final velocity is v. Okay, so w is equal to how much? U to v change होची माने velocity. आमे कौन करि परिबो जेतोळे टोटल वर्क डन आमे काढिबा, we have to integrate dw, okay, over u to v. Okay, integration over dw. Here dw value is written mv dv. So just put it here mv dv, integration over u to v. Okay, m is a constant, so it will be taken out. Okay, so m integration over u to v, v dv. Correct? Now m, what is the integration of v dv? You can tell me. That is v square by 2. Okay, then the limit is u to v. Achha, when I am solving this part, I will get half mv square minus half mu square. That is equal to how much? Previously we have discussed now, half mv square is the final kinetic energy. Half mu square is the initial kinetic energy. So kf minus ki. Okay, w is equal to kf minus ki, which is the change in kinetic energy of the body. Previously also we have got the same thing. Correct? So this is all about the work energy theorem for a variable force. Okay, students, today we have discussed about the two parts of the work energy theorem. That means the two type of derivation of the work energy theorem, that is for a constant force as well as for a variable force. Okay, we go through it. In the next class we will go for some numericals related to work energy theorem. Thank you all.